Good morning to all you incredibly diligent students. My name is Joab Brockman, and here's another short video on how to perform chemical engineering calculations using a not-so-simple calculator. Today we're continuing our journey to use the calculator as an easy way to solve thermodynamic and other types of problems. This time we're going to use the successive substitution method on a series of equations. First, let's wade into some theory. Here's the problem statement. For those of you who've learned chemical engineering thermodynamics, it's a classic. We're going to calculate the outlet temperature of a gas with a known specific heat function, while the total amount of energy, or as it's called in industry, the duty, is defined. The amount of heat Q, or duty, in a constant pressure process is equal to the change of enthalpy, delta H, and for a pure substance with no phase change or reaction, is given as the integral of the constant pressure specific heat Cp. So Q equals N times delta H equals the integral from T0 to T of Cp dt, where Cp is given in dimensionless form as Cp over R equals A plus Bt plus Ct squared plus d over t squared. Integrating this to calculate Q yields the expression Q equals N times delta H equals N times R times brackets A plus B over 2 times T plus T0 plus C over 3 times T squared plus T times T0 plus T0 squared plus d over t times t0, all this times t minus t0. And the expression in the parenthesis multiplied by R is known as the average enthalpy-based specific heat. This is easy to solve if T0 and T are known and we want to calculate the enthalpy change delta H or Q. However, it's a little harder to solve if Q and T0 are provided for and we're trying to find the value of T. Let's divide the expression into two and rearrange them. First, we'll calculate the average Cp value, assuming a known, predefined value for T. A good initial guess would be for T to be equal to T0. So we have Cph of I equals R times the expression in the brackets, where Ti is known, and we've pre-assumed T, so we can now obtain an initial value for Cp of H. Now use this value to obtain an updated value for T. So Ti plus 1, the next value for T, will be equals to Q divided by N times the average Cp. This we add to T0. And now we use this value of T to calculate an updated value for Cp of H. We repeat this until the values for Cph and T converge. To summarize the method, make an initial guess for T, example T equals T0, calculate Cp of H using an updated value for T, calculate new T using the value for Cp of H, and iterate this until convergence. Let's give a specific example. The problem we're going to solve is defined as finding the final temperature when heat in the amount of 36,000 kilojoule is added to 1 kilomole of ammonia, initially at 530 Kelvin, in a steady flow process at 1 bar. For ammonia, the values of A through D are given as A equals 3.578, B equals 3.020 times 10 minus 3, C equals 0, and D equals minus 0.0186 times 10 in the fifth. Since C equals 0 for ammonia, the equation for Cp of H is simplified to Cp of H equals R times brackets A plus B over 2, Ti plus T0, plus D over Ti T0, close brackets. Now let's set this up in our calculator. First, we'll assign values to the A, B, and D constants by typing the value for A as 3.578 and pressing the store, the STO button, and then the minus, which has the red letter A listed above it. In the same way, we do this for B and D. So we have 3.020 times 10 minus 3 store, and the comma button for B. and minus 0.0186 times 10 to the fifth, store, and the sign button for D. Assigning constant values A, B, and D allows the expressions to be easier to handle and also allows changing these quickly for other substances. Now make an initial guess for T. We'll assume it equals T0 530. So type 530 in the calculator and press the equals button. Answer is now equal to 530. We now type two expressions in series using the colon button, which is found using the alpha integral combination. The first expression calculates Cp of h, and instead of t, we enter answer. So we have 8.314 times a plus b over 2 times answer plus 530 plus d divided by 530 times answer. Close the brackets. Following this, we enter the colon button, the alpha integral combo, and then type the second expression. This calculates an updated value for t. So now we type 36,000 divided by answer plus 530. All in all, the total expression looks like this. The first expression on the left-hand side calculates Cp of h. The second expression after the colon calculates an updated value for t. Pressing the equals button first time calculates the left-hand expression, resulting in answer being equals to Cp of h. Pressing the equals time an additional time takes the current answer value and sets it into the right-hand expression to calculate a new, updated value for answer, which now represents t. Pressing the equal sign repeatedly will iterate between the two expressions, and the values will gradually converge to constant values of Cp of h equals 51.76 and T equals 1225.49 Kelvin. Note that convergence using this method is relatively slow. That's all for now. Next time we'll solve this same example using the internal solver function of the calculator. I hope you enjoyed this video. This is Yoav Rockman saying to all you diligent students, keep up the good work.